Hello and welcome to the session on Special Theory of Relativity, Part 3. Simultaneity and Synchronization. Consider two events occurring at the same time t and at two different points x1 and x2 in the system S. For the observer in S dash, these events would appear to occur at times t1 dash and t2 dash given by t1 dash is equal to gamma into t minus v by c square x1 and t2 dash is equal to gamma into t minus v by c square x2, t1 dash not equal to t2 dash. Thus, two events which are spatially separated and simultaneous in the frame S is not simultaneous in S dash frame unless x1 is equal to x2. Thus, simultaneity of spatially separated events is not an absolute property as was considered in Newtonian relativity. Let t is equal to 0, then t dash is equal to minus gamma v by c square x. This equation means that at t is equal to 0, if an observer in S observes various clocks kept in S dash at different points on x axis, they will read differently with the clocks to the right of origin, behind and to the left ahead by an amount in proportion to their distance x from the origin. Only the clock kept at the origin of S dash will read t dash is equal to 0. All the clocks in S frame are synchronized and they show the same time. But even though the clock in S dash are synchronized and they show different time because for the observer in S they are in motion. The same thing will be spoken by the observer in S dash. According to him, all the clocks in S dash are synchronized and all show the same time, but the clocks in S will not show the same time. That is, they are out of synchronization. Einstein's velocity addition rule. Let the coordinates of a particle in the frame S be x, y, z, t, and in S dash be x dash, y dash, z dash, t dash. The components of its velocity in the two frames can be written as ux is equal to dx by dt, uy is equal to dy by dt, uz is equal to dz by dt in the S frame, and ux dash is equal to dx dash by dt, uy dash is equal to dy dash by dt, uz dash is equal to dz dash by dt in the S dash frame. The inverse transformation equations are x is equal to gamma x dash plus vt dash, y is equal to y dash, z is equal to z dash, t is equal to t dash plus vx dash by c square. Taking differentials, dx is equal to gamma dx dash plus v dt dash, dy is equal to dy dash, dz is equal to dz dash, and dt is equal to gamma dt dash plus v dx dash by c square. Therefore, ux is equal to dx by dt, which is equal to gamma dx dash plus v dt dash divided by gamma dt dash plus v dx dash by c square, which is equal to dx dash by dt dash plus v, all divided by 1 plus v by c square into dx dash by dt dash. Ux is equal to ux dash plus v, all divided by 1 plus v ux dash divided by c square. Let it be equation number 1. Uy is equal to dy by dt, which is equal to dy dash divided by gamma dt dash plus v dx dash by c square, which is equal to dy dash by dt dash divided by gamma 1 plus v by c square into dx dash by dt dash. Uy is equal to uy dash divided by gamma 1 plus v ux dash by c square. Let it be equation number 2. And uz is equal to uz dash divided by gamma 1 plus v ux dash divided by c square. Let it be equation number 3. The set of equations 1, 2 and 3 gives the relativistic law of addition of velocities. But according to classical mechanics, the law of addition of velocities is ux is equal to ux dash plus v, uy is equal to uy dash, and uz is equal to uz dash. From equation 1 we have u is equal to u dash plus v all divided by 1 plus v u dash by c square. Using Lorentz transformation equations, we can show that ux dash is equal to ux minus v all divided by 1 minus v into ux divided by c square. Uy dash is equal to uy divided by gamma 1 minus v into ux by c square. Uz dash is equal to uz divided by gamma 1 minus vux by c square. To show that the velocity of light is the same for all inertial frames, whatever their relative speeds may be. Consider a photon moving with a velocity c in the frame s dash. Let the frame s dash move with a velocity c relative to s along the positive x axis. Then ux is equal to ux dash plus v all divided by 1 plus v into ux dash by c square, which is equal to c plus c all divided by 1 plus c square by c square, which is equal to 2c divided by 2 is equal to c. Hence, the velocity of light is the same for the inertial frames, whatever their relative speed may be. Variation of mass with velocity. The mass of a body is measured by an observer at rest with respect to the body is called the proper mass or rest mass, denoted by m naught. When the body moves with a velocity v, then according to the theory of relativity, the mass also increases with velocity. The variation of mass with velocity is given by m is equal to m naught divided by square root of 1 minus v square by c square. In figure 1a, s and s dash are two inertial frames. The frame s is at rest and s dash moves along positive x axis with a uniform velocity v. Consider an elastic collision between two particles A and B, which are separated by a vertical distance y. Before collision, A is at rest in frame S and B is at rest in frame S dash. Next, A was thrown in the positive y direction with a speed Va and B was thrown in the negative direction with a velocity Vb dash at the same instant, such that Va is equal to Vb dash. This means the observation made by the observer in the frame S about A is the same as that made by the observer in the frame S dash about B. Let the two particles collide after travelling a distance y by 2 each. After collision, A rebounds in the negative y axis with a speed of Va and B rebounds with a speed Vb dash in the positive y dash direction. For the observer in the S frame, the collision occurs at y is equal to 1 by 2 into y, and for the observer in S dash, the collision occurs at y dash is equal to y is equal to 1 by 2 y. The time taken for the round trip by A as measured in the S frame is t naught is equal to y divided by Va, let it be equation number 1, and that for B as measured in the S dash frame is t naught is equal to y divided by Vb, let it be equation number 2. For the conservation of linear momentum, we have ma into Va is equal to mb into Vb, let it be equation number 3, where ma and mb are the masses of A and B, and Va and Vb are the velocities as measured in the S frame. In the S frame, we can find the speed of B, Vb using the equation Vb is equal to y divided by t, let it be equation number 4, where t is the time needed for B to make its round trip as measured by the observer in S. But in S dash, the time taken for the round trip is t is equal to t naught divided by square root of 1 minus v square by c square, let it be equation number 5. Substituting the value of t in equation 4, we get Vb is equal to y divided by t naught into square root of 1 minus v square by c square, let it be equation number 6. From equation 1, Va is equal to y divided by t naught, let it be equation number 7. Substituting the values of Va and Vb in equation 3, we get Ma is equal to y divided by t naught, which is equal to mb into y divided by t naught into square root of 1 minus v square by c square. mb is equal to ma divided by square root of 1 minus v square by c square. For the observer at the frame S, the particle A is at rest. So, the mass m a is equal to m naught is the rest mass, but the particle B is in motion in frame S dash. So, its mass is the mass of the particle motion, that is m b is equal to m. So, m is equal to m naught divided by square root of 1 minus v square by c square. This equation shows that mass of a particle increases with its velocity. The increase in mass is reciprocal. We can feel the increase in relativistic mass at speeds closer to that of light. When the speed is c by 10, the increase in mass is only 0.5%, but when the speed is 9c by 10, the increase in mass is about 100%. Problem: calculate the mass of an electron whose velocity is 0.99 c. The rest mass of electron is m naught is equal to 9.1 into 10 raised to minus 31 kilogram. Answer: m is equal to m naught divided by square root of 1 minus v square by c square, which is equal to 9.1 into 10 raised to minus 31 divided by square root of 1 minus 0.98, which is equal to 64 into 10 raised to minus 31 kilogram. Relativistic mass energy relations. The relativistic energy of particle having relativistic mass m is given by E is equal to mc square. But there is no relation connecting mass and energy in classical physics. Derivation. According to Newton's second law of motion, force is defined as the rate of change of momentum, that is F is equal to d by dt of mv. According to the theory of relativity, both mass m and velocity v are variable. So, F is equal to d by dt of mv, which is equal to m into dv by dt plus v into dm by dt. Let it be equation number 1. Under the action of the force, the body moves through a distance dx, so that the work done is F into dx. This work done increases the kinetic energy of the particle by dEk. dEk is equal to F dx, which is equal to m into dv by dt dx plus v into dm by dt dx. But v is equal to dx by dt, therefore dEk is equal to mv into dv plus v square dm. Let it be equation number 2. The relativistic mass of a body at rest mass m naught moving with a velocity v is m, where m is equal to m naught divided by square root of 1 minus v square by c square. Squaring both sides, m square is equal to m naught square divided by 1 minus v square by c square. M square c square is equal to m naught c square plus m square v square. Differentiating, we get c square into 2m dm is equal to m square into 2v dv plus v square into 2m dm, that is c square dm is equal to mv dv plus v square dm. Let it be equation number 3. From equation 2 and 3, dEk is equal to c square dm. Let it be equation number 4. When a body is at rest, the velocity is 0, kinetic energy is 0 and its mass is m naught. When the velocity of the body is v, its mass is m. Integrating equation 4, the relativistic equation for kinetic energy Ek is equal to integral from 0 to Ek dEk, which is equal to c square into integral from m naught to m dm, which is equal to c square into m minus m naught. Ek is equal to m c square minus m naught c square. When the body is at rest, the energy stored in it is m naught c square and is called the rest mass energy or proper energy. The total energy E of a body is the sum of kinetic energy Ek and the rest mass energy m naught c square. E is equal to Ek plus m naught c square, which is equal to m c square minus m naught c square plus m naught c square, which is equal to m c square. That is, E is equal to m c square. This is the Einstein's mass energy relation for the relativistic energy of a body, which says that mass can be converted into energy and vice versa. To show that the relativistic energy reduces to the classical formula when V is very smaller than C. Ek is equal to E minus E naught, which is equal to mc square minus m naught c square, which is equal to m naught c square into 1 minus V square by C square, the whole raised to 1 by 2 minus m naught c square, which is equal to m naught c square into 1 plus 1 by 2 into V square by C square plus 3 V raised to 4 by 8 C raised to 4 plus etc. minus m naught c square. When V by C is very smaller than 1, we have Ek is equal to m naught c square plus m naught c square into V square by 2 C square minus m naught c square is equal to 1 by 2 into m naught V square. This is the classical formula for the kinetic energy of a body. Principle of equivalence of mass and energy. The relativistic equation for the kinetic energy of a body is Ek is equal to mc square minus m naught c square from equation 5. Delta Ek is equal to delta mc square. This equation means that there is an increase in kinetic energy of a body when its mass changes by delta m. In general, we can say that an amount of energy delta E in any form is equivalent to a mass delta m is equal to delta E divided by c square, and conversely any mass delta m is equivalent to an energy delta E is equal to delta mc square. This is called the principle of equivalence of mass and energy. Significance of mass energy relationship. Einstein's mass energy relation is E is equal to mc square. This relation shows that mass and energy are interconvertible, that is, mass can be converted into energy and vice versa. This equation shows that the separate principles of conservation of mass and energy are actually a single principle of mass energy conservation. The relationship also shows that the annihilation of even a small amount of mass yields a large amount of energy. Electron-Positron Annihilation. Electrons and positrons are elementary particles. The charge of electron is negative while that of positron is positive, but both have the same mass m. When an electron meets a positron, they annihilate with the production of gamma rays. It was experimentally verified that the energy of gamma rays is equal to the total energy 2mc square of the electron and the positron. The reverse reaction, vice versa, the pair production also supports Einstein's mass energy equivalence. In pair production, whenever a gamma ray photon disappears, it appears in the form of a positron and electron. Nuclear energy. The decrease in the nuclear mass appears as energy in the case of nuclear fission and nuclear fusion. In nuclear fission, a heavy nucleus like uranium-235, when bombarded with slow neutrons, splits into a lighter nuclei. The total mass of the products is found to be less than that of reactants. If the mass difference is delta m, then it appears an energy in accordance with the equation delta E is equal to delta mc square. In nuclear fusion, lighter nuclei fuse together to produce a heavy nucleus with the release of energy as in the case of nuclear fission. The solar energy is produced to the fusion of protons to form helium. Atom bomb based on nuclear fission and hydrogen bomb based on nuclear fusion supports Einstein's mass energy relation. During other nuclear reactions also energy is released, which is the energy equivalent of the difference in masses of reactants and the products. Relativistic formula for momentum and energy. Relativistic momentum P is equal to m naught V divided by square root of 1 minus V square by C square. P square is equal to m naught square V square divided by 1 minus V square by C square. P square C square plus m naught square C raised to 4 is equal to m naught square V square C square divided by 1 minus V square by C square plus m naught square C raised to 4, which is equal to m naught square V square C square plus m naught square C raised to 4 minus m naught square v square c square all divided by 1 minus v square by c square, which is equal to m naught square c raised to 4 divided by 1 minus v square by c square, which is equal to e square. Therefore, e square is equal to p square c square plus m naught square c raised to 4, or e is equal to square root of p square c square plus m naught square c raised to 4. E square minus p square c square is equal to m naught square c raised to 4. Since m naught and c are constants, e square minus p square c square is a Lorentz invariant and its value remains unaltered in any inertial frame of reference. Transformation of relativistic momentum and energy. The momentum of a particle in the inertial frame S is vector p. If px, py and pz are the components, then px is equal to m into ux, which is equal to m naught ux divided by square root of 1 minus u square by c square. Py is equal to m naught uy divided by square root of 1 minus u square by c square. Pz is equal to m naught uz divided by square root of 1 minus u square by c square. Total energy E is equal to mc square, which is equal to m naught c square divided by square root of 1 minus u square by c square. The momenta components in the frame S dash are px dash is equal to m dash ux dash is equal to m naught ux dash divided by square root of 1 minus u dash square divided by c square. Py dash is equal to m naught uy dash divided by square root of 1 minus u dash square divided by c square. Pz dash is equal to m naught uz dash divided by square root of 1 minus u dash square divided by c square. And E dash is equal to m dash c square, which is equal to m naught c square divided by square root of 1 minus u dash square divided by c square. But ux dash is equal to ux minus v all divided by 1 minus vux divided by c square, and 1 divided by square root of 1 minus u dash square by c square is equal to 1 minus vux by c square all divided by square root of 1 minus v square by c square into square root of 1 minus u square by c square. Substituting in the equation px dash is equal to m naught ux dash divided by square root of 1 minus u dash square by c square, we get px dash is equal to m naught into ux minus v divided by 1 minus vux by c square into 1 minus vux by c square all divided by square root of 1 minus v square by c square into square root of 1 minus u square by c square is equal to m naught divided by square root of 1 minus u square by c square into ux minus v all divided by square root of 1 minus v square by c square, which is equal to gamma into mux minus mv, which is equal to gamma into px minus ve divided by c square. Similarly, by substituting the values of py dash and pz dash, we get py dash is equal to py and pz dash is equal to pz. E dash is equal to m dash c square, which is equal to m naught c square divided by square root of 1 minus u dash square by c square, which is equal to m naught into 1 minus vux by c square into c square all divided by square root of 1 minus v square by c square into square root of 1 minus u square by c square, which is equal to gamma m c square into 1 minus vux by c square, which is equal to gamma e minus vpx. The momentum transformation equations are px is equal to gamma px dash plus ve dash by c square, py equal to py dash, pz is equal to pz dash, E is equal to gamma E dash plus Vpx dash. We can show that P square minus E square by C square is an invariant. P dash square minus E dash square by C square is equal to Px dash square plus Py dash square plus Pz dash square minus E dash square by C square, which is equal to gamma square into Px minus Ve by C square the whole square plus Py square plus Pz square minus gamma square into E by C minus Vpx by C the whole square, which is equal to Px square plus Py square plus Pz square minus E square by C square is equal to P square minus E square by C square. If S dash is the rest frame of the particle, then left hand side is equal to minus m naught square C square. That is, C square P square minus E square is equal to m naught square C raised to 4. E is equal to plus or minus square root of P square C square plus m naught square C raised to 4. Thus, energy can be positive or negative. Dirac gave a physical meaning to the negative energy. Problem: a nucleus of rest mass m naught is stuck by a photon of energy h nu, which is completely absorbed. Determine the recoil velocity v of the combined system. Answer: by the law of conservation of linear momentum, E is equal to m naught c square plus h nu, which is equal to m dash c square. P is equal to h nu by c is equal to m dash nu, where m dash is the mass of the combined system. Nu by c is equal to h nu by m dash c square, which is equal to h nu by m naught c square plus h nu. When h nu is very smaller than m naught c square, V by c is equal to h nu by m naught c square. V is equal to h nu by m naught c. Let me summarize what we have discussed so far. The simultaneity of spatially separated events is not an absolute property, as was considered in Newtonian relativity. The relativistic law of addition of velocities is given by the equations ux is equal to ux dash plus v all divided by 1 plus v ux dash by c square, uy is equal to uy dash divided by gamma into 1 plus v ux dash by c square, uz is equal to uz dash divided by gamma into 1 plus v ux dash by c square. The variation of mass with velocity is given by the equation m is equal to m naught divided by square root of 1 minus v square by c square. The relativistic energy of particle having relativistic mass m is given by E is equal to mc square. The relativistic equation for kinetic energy of a body is delta Ek is equal to delta mc square. The momentum transformation equations are Px is equal to gamma into Px dash plus nu E dash by c square, Py is equal to Py dash, Pz is equal to Pz dash, E is equal to gamma into E dash plus nu Px dash. Now you can try to answer the questions given here. First one, what do you mean by simultaneity for relativity? Second one, obtain an expression for the total energy of a particle when it is moving a velocity v. Third one, derive Einstein's mass energy relations. Fourth one, state Einstein's velocity addition theorem and prove that this is in agreement with the principle of constancy of speed of light. Fifth one, state the principle of mass and energy equation, illustrate with examples. You may go through these books for reference. First one, The Meaning of Relativity by Albert Einstein. Second one, Physical Relativity by Harvey R. Brown 2005. Third one, Classical Dynamics of Particles and Systems, 4th edition by S.T. Thornton and J.B. Marion. Fourth one, Engineering Mechanics, 5th edition by J.L. Marion and L.G. Craig. Thank you for watching this program. Hope that this topic was beneficial for you. We can meet again with another topic. Till then, take care.